All right, let's jump right into this explainer. If you spend your days managing warehouse operations or working as a controls engineer, you already know the massive headache of keeping automated sorters running smoothly. If you've ever had to commission a sorter, you've definitely felt the pain of trying to keep product flowing while dealing with the absolute chaos of nuisance alarms. Well, today we are looking at a real game changer, Zebra's AI jam detection using the Iris GTX Smart Camera and Aurora software.
So, tell me if this sounds familiar. Have you ever walked all the way out to a jam that wasn't even there? Every single controls engineer knows this exact failure mode. The line abruptly stops, the alarms start blaring, an associate drops whatever they are doing to hike all the way out to the induct and nothing. Absolutely nothing. The package actually cleared itself 2 seconds after the alarm fired, but the line is still dead. You're just out there chasing a ghost.
Which brings us to part 1, the problem, the phantom jam.
Now, these ghost jams aren't just a minor annoyance. They are actively destroying your facility's efficiency and causing serious alert fatigue on the warehouse floor. To understand why this keeps happening, we have to look at the contrast in the logic being used. On one hand, you have traditional binary sensor logic. A photo eye or a light curtain operates on a super simple rule. If the beam is blocked longer than X milliseconds, trigger a fault. It is incredibly rigid. But on the other hand, you have AI contextual logic. This approach completely replaces that basic binary rule with a machine vision model that actually evaluates the flow of the packages in context. It asks a much smarter question. Is this just a moving pile that's going to clear itself, or is it an actual mechanical fault?
Now, to be fair, the photo eye sensor itself isn't wrong. It's just answering the one specific question it was designed to ask. A photo eye only reports a single bit of data, blocked or clear. The jam logic sitting in your PLC takes that one bit and turns it into a fault by adding a simple timer. But here's the catch. That timer threshold is a trap. If you set the timer too tight, well, every slow-moving polybag or shingled pair of cartons throws an alarm. But if you set it loose to stop all those nuisance trips, you end up delaying the detection of real jams, the kind that actually crush product and back up the whole induct. There's literally no perfect timer setting because the sensor physically cannot see package orientation and it cannot see motion. It only sees a beam.
Moving on to Section 2, adding space and time. So how do we fix this? We have to shift from a simple, one-dimensional sensor to a multi-dimensional vision system. Let's baseline exactly what this technology is. AI-powered jam detection is a machine vision application that watches a conveyor or a sorter region continuously. It classifies what it sees as either a true mechanical jam or just a temporary, self-resolving blockage. And crucially, it only sounds the alarm for the real mechanical jams.
The AI pulls this off by adding 2 critical dimensions that a basic photo eye just doesn't have: spatial context and time. First up, spatial context. Instead of just a single-point sensor, the camera monitors a defined region of interest. On a multi-lane sorter, one camera can actually cover several lanes purely in software. Second is temporal context, time. Think about it. 2 cartons riding skewed through a curve and 2 cartons wedged against a rail might look completely identical in a single snapshot. But across a sequence of frames, they don't. The skewed pair keeps moving. The wedged pair stays stuck. The AI is constantly evaluating that flow and trajectory over time. It knows that a false jam has a resolution trajectory and a true jam just doesn't.
And this leads us to a massive aha moment from the research. The real cost here is not the stoppage. It is the labor. A false jam alarm pulls a worker right off a pick wall or a pack station and forces them to walk to a sorter that's probably already running again. Multiply that walk by an entire shift across every lane right in the middle of peak season. What you get is severe alert fatigue. When most alarms mean absolutely nothing, response times for the real alarms completely plummet. So this technology, it's functionally a critical labor allocation tool that just happens to be wearing a sensor's clothes.
All right, part 3, edge computing on the camera.
Now, the real magic here happens right on the edge. You don't need to overhaul your entire server room. Specifically, we're looking at the Zebra Iris GTX Smart Camera. The processing happens directly on the device itself. It's rocking an Intel Atom X6211E dual-core processor, along with 4 gigs of memory and 32 gigs of eMMC storage. So what does that mean for you on the floor? It means there is no bulky vision PC required in the loop. The inference and the region logic execute right there on the camera, which then talks directly to your PLC or WCS. This is an absolute lifesaver for mezzanine installs where you simply don't have cabinet space or an extra Ethernet drop to spare. Let's break down these camera specs. The Iris GTX gives you a matrix of options.
And resolution is the key variable that decides how many lanes one camera can cover at your working distance. So, a GTX 8000 with its 4K resolution holds a much wider region than the GTX 2000. Now, I want to highlight something super important here: monochrome versus color. For jam detection, monochrome is usually the correct and, honestly, the cheaper answer. Why? Because the AI keys in on geometry and motion, not on hue. Don't buy a color camera just for future flexibility unless you absolutely know you'll need it for something like label presence. Otherwise, you're paying for pixels you're never going to use, and you're actually losing low-light sensitivity in the process.
That brings us to Section 4, Hardware and Setup Reality.
So what does it actually take to bring this to life on the floor? The software running the show is Zebra's Aurora platform, specifically the Aurora Design Assistant. It's a flowchart-based IDE. That means you build the application by wiring logical steps together rather than typing out endless lines of code. It's really built for engineers, not programmers. But one major pro tip from the source material: triple-check your runtime license feature bundles before you place an order. You specifically need the classification feature to run the AI. The difference between getting your line up and running by Monday versus waiting a whole week for a license amendment is literally just paying attention to one column on your quote. Now, let's talk physical setup hierarchy. This is where things get really practical, and honestly, it's the part that gets underestimated way too often. Step 1 is optics and lensing. Your desired field of view and your mounting height will dictate your focal length. Step 2 is lighting, and this is absolutely critical. Overhead facility lighting changes shift by shift and season by season. An AI classifier trained under one specific set of lights will experience model drift if that illumination suddenly changes. That's exactly why controlled LED bar lighting is highly recommended, even if you think your facility already has plenty of light. Finally, step 3 is mounting. Always account for the fact that mezzanine installs usually require longer working distances than anyone assumes during the initial quoting phase. Okay, let's talk about training your AI model. Do you need to hire a data scientist for this? No, absolutely not. The software is built for engineers. But do you actually need to train it? Yes, and this is totally non-negotiable. You have to budget proper commissioning time for image collection from your actual live line. You must train it on your real-world mix: the polybags, the corrugated boxes, and those super low-friction Jiffy mailers. And don't forget to include those oversized items that only seem to show up during peak season. If a model is trained purely on one clean, perfect square carton, it's going to fail the exact second a mailer goes through sideways. You really have to show the AI the messy reality of your line. Real quick aside here. What if the Iris GTX is just overkill for you? Say you just need a really simple presence check at a fixed station. Well, take a look at the Zebra VS series, the VS 20, 40, or 70. The beauty of these is they all run on that exact same Aurora software platform, which means your engineering team only has to learn one single tool chain to manage everything. Let's get down to business in Section 5. Real ROI and labor savings.
So, Zebra reports an up to 30% increase in throughput on outbound sorter applications when this system replaces basic sensor-based jam logic. 30%. That is a huge number. But let's add some necessary nuance here. That 30% figure is really a best-case scenario for a line whose throughput was being severely suppressed by false positive stoppages. If your line doesn't actually stop that often to begin with, you probably won't see a 30% bump in pure throughput.
So how do you figure out your own real-world payback? Well, here is the exact formula. First, grab your jam alarm counts for a full month. Second, measure the stoppage durations. Third, estimate what fraction of those stoppages were actually just self-clearing nuisance trips. Finally, multiply that by the labor time your associate spent walking to those phantom jams. Even if your false positive rate is fairly low, your payback is still going to be highly valuable, just in terms of better labor allocation and reducing alert fatigue. But if your people are walking out to phantom jams multiple times a shift, the financial savings get very interesting very quickly.
Before we wrap this up, I want to make a really important technical clarification. Does this AI replace your photo eyes? Well, it replaces the photo eye plus timer logic that was trying to make a complex judgment call it just wasn't built for. But let's be absolutely crystal clear. Anything on your line performing a safety function stays exactly where it is. A smart camera is not a substitute for a safety-rated device. Your safety photo eyes are staying put.
Which brings us to our final thought for this explainer. How much is your alert fatigue really costing you? Seriously, think about it. It's not just the downtime, it's the wasted steps, the ignored warnings, and the misallocated labor. By replacing blind timers with actual visual context, you aren't just fixing a broken sensor, you are reclaiming your workforce's time. Thanks so much for joining me on this explainer today, and I hope this gives you a much clearer picture of how to solve the phantom jam once and for all. Keep learning, and I'll catch you next time.